So good evening everyone. Can you all hear me and can you see the screen clearly? All of you please respond. Good evening. So can you all hear me and can you see the screen clearly? If yes, please type in the chat box. Suresh. Okay. Yes. Hi Kaniti. So shall we start? So if you quickly recall past, 3 lectures, we have talked about limits in the first lecture and have seen different techniques for evaluating limits of different functions at different points on a y-axis. And in the second lecture, we have talked about continuity and differentiability. Basically, we have seen how to define the condition for continuity of a function, and the continuity condition is defined as limit at that particular point should be equal to functional value. And also in the third lecture, we talked about mean value theorems and the Taylor series expansion of the single variable. Correct? So in mean value theorems, basically we talked about this Lagrange's mean value theorem, which is the base for the other two theorems known as Rolle's and Cauchy's mean value theorem. Correct? And then we stepped into Taylor series and we have seen how to determine Taylor series expansion of any differentiable function at a given point. Correct? Is that clear so far? Is that clear to all of you as of now? Please respond. All of you please respond. Is that okay to all of you? So now in today's class, we deal about one very important topic, which is called the concept of maxima and minima. Correct? And this concept is, quite applicable in many of your core disciplines. Correct? And this maximum and minimums, points where we get maximums or minimums are really important, because let us suppose if you are establishing a business, you need to know the main points which makes your profit to be maximum. Correct? Similarly, if you are having some loss, you need to know at what conditions the loss can be minimized. Similarly, it can hold good in many of your core subjects. So this concept is really important, and for this you need to have some knowledge. Let us see that. So this is the fourth lecture. Anyhow, we know we are talking about concept of maxima and minima. So now let us see what are the procedures for concept of maxima and minima. And in yesterday's class, when dealing about Rolle's theorem, you have seen if there is a function such that if it's having a maximum at any given point, there comes the slope of the tangent to be 0. This is what you have seen, correct? This is some point x is equal to c, and this is x is equal to a, and of course this is x is equal to b. So this is what you have seen. Now let us generalize this scenario for finding this maxima and minima of any function. Okay, but the condition is the function should be differentiable continuously. Okay, so see here, if f of x is any function, is any differentiable function, is any differentiable function, then the procedure for finding maxima or minima is as follows. See, this concept is really important because a lot of questions have been they've been asking in GATE examination, and today we'll solve quite good number of questions actually. Okay, and those problems which we put in this presentation are really good problems, so please stay tuned all this entire class. So for finding maxima minima is as follows. Now first up, one thing, whenever there is a maxima or minima at that particular point of x, this derivative of the function at that point is 0. Means if you want to find the derivative, if you want to find the maximum or minimum of the function, or if you want to find the extreme values of the function, the first thing you need to do is you need to find the derivative and equate it to 0 and find the value of c, where the maximum can occur or the minimum can occur if the curve is in the reverse direction. So if you see, first up you need to find stationary points. What are stationary points? Find stationary points. And what are stationary points? The points where this f dash of x, means the first derivative of this function, are 0. Now, depending upon the given function, you can have many number of stationary points. Okay, because suppose if you are dealing with a quadratic function, then if you differentiate it once, you will be getting a linear function for which there will be only one stationary point. Because if you solve a linear equation, of course in a single variable, you will get only 1 point. Similarly, if this f of x is a cubic function, then when you differentiate and calculate f dash of x, you will be getting a quadratic function, which is again, when you solve, you can have two values of x. So, because this f dash of x has to exist, Akshay, that's why we assume that this is differentiable function at least twice to calculate maximums or minimum. Okay, because this f dash of x has to exist if you want to equate it to 0. Okay, so that's why the function need to be differentiable. Now, first thing is, you will calculate this f dash of x and you will equate it to 0. Now, depending on this function, you can get any number of stationary points. Now, I am considering the case for one stationary point. Okay, let x not be a stationary point. I am talking about one stationary point. Okay, x not be a stationary point. Now, second step, calculate f double dash of x naught. See, when you equate f dash of x to 0, Kaniti, Telugu classes are not yet started, but we are planning to start soon. Okay, so see here, for the timing you can understand English, so you can look here. So calculate f double dash of x naught. See, once you find the differentiation, first derivative, and when you equate it to 0, then you will be getting certain number of points, correct, depending upon the nature of the function. So I am explaining this criteria for one of such points. So now calculate f double dash of x naught. First step, if f double dash of x naught is greater than 0, then the function f of x has minimum at x is equal to x naught, and the minimum value is f of x naught. And in my previous course of basic mathematics, I have already given the explanation why this f double dash of x naught has to be greater than 0. Did you all remember this? Whoever has attended my previous course, they can understand why for having minimum at a function at a point, this f double dash of x naught has to be greater than 0. Do you all remember this? We have talked about this. Why for attaining minimum, this f double dash of x naught should be greater than 0. Clear to all of you? Do you all remember this? We have talked about this. So since this is a revision course, I am not going into depth again. So I am just giving you this statement. If you want the explanation for this, you can refer my basic course on mathematics, which I have already taken and uploaded on this channel. So you can refer that. Second point, if f double dash of x naught is less than 0, then the function f of x has maximum at x is equal to x naught, and the maximum value is f of x naught. Okay, sometimes in exams they'll ask you for something like this. Sometimes they don't ask you for the minimum value, they'll ask you the point or the value of x at which it is maximum. When they ask you, if they're asking you the point where this f of x has maximum, your answer should be this x naught. Okay, sometimes you need not do the complete question and you need not enter this f of x naught, because in the questions they'll be asking you for this value of x where this function attains a maximum. Okay, so we have done with two cases, greater than 0 and less than 0. Now what's left with us? We have a third case when this double derivative is equal to 0. If f double dash of x naught is equal to 0, then we can't comment on maximum or minimum. Then we can't comment on maximum or minimum. Okay, and whenever such cases arise, you need to have knowledge on graphs and or some other analysis for the functions, and you should be in a position to answer this. Okay, because when this f double dash of x naught is equal to 0, you say that this second derivative test is failing because we can't comment anything on the extremum of the function. Clear? Are you all clear with how to identify this maximum or minimum values of a function? Is that clear to all of you? You will calculate the first differentiation and equate it to 0. So you will be getting certain number of stationary points. Then you will repeat this step 2 for each and every stationary point. Clear? I have discussed the procedure for one such stationary point. Is that clear to all of you? And if you want the explanations why for attaining this minimum value, this f double dash of x naught has to be 0, you can visit my previous course on engineering mathematics, which is already available on this channel. Okay, since this is revision, I am going ahead soon. Next, I just want to talk about one important category of functions which is increasing and decreasing functions, because this is really important. Increasing and decreasing functions. Now let us first talk about increasing functions. Increasing functions. Now what is an increasing function? See, you can call this point as, in such cases, this point is called, this point x is equal to x naught is called, you might note it with some name, is called critical point, because this case is critical to analyze, of course. So critical point, or you can also call this point as, few books name this as point of inflection. Point of inflection. These two are just names for this kind of points where even the both first and second derivatives are 0. For example, if you want to see here, look, I would like to give an example. In yesterday's class, I have already given, you have seen that if f of x is equal to x cube, see, if I want to draw the graph of f of x is equal to x cube, this is 0, x, minus x, y, and minus y. And if you want to draw the graph of this, it looks something like, you can find a point of inflection here where this f of 0 is 0, because when you put x is equal to 0, this y value is 0, and this implies f dash of x is equal to 3x square. So if you equate the first derivative to 0, you will be getting the stationary point as 0, correct? Because x square is equal to 0. Now if you calculate the second derivative, f double dash of x is equal to, see, first derivative is 3x square, so what could be the second derivative? It is 6x. But if you calculate the second derivative at this particular point, x is equal to 0, which is the stationary point, your answer is again 0. So f double dash of x is equal to 0. So we can't comment about maximum or minimum. So then you need to go for something graph like this, and you can see this function, even though the first derivative is 0 here, this function y is equal to x cube doesn't have either maximum or minimum at this point, correct? Because the minimum value goes to minus infinity and the positive value goes to plus infinity. So this is the case where the second derivative test fails generally, whenever this second derivative at that particular stationary point is also 0. Clear so far? Is that okay to all of you? Can we move ahead from this point? And we say this x is equal to 0 is called point of inflection or critical point for this function. Fine to all of you? Can I move ahead? Okay. So now we are talking about increasing functions. Do you have any knowledge on increasing functions? Or do you know when a function can be called an increasing function? Any idea from your classical knowledge or basic undergrad knowledge? Slope is always positive at all increasing values of x for increasing function. First derivative greater than 0. Okay. So see here, a function f of x is said to be increasing. A function f of x is said to be increasing if f of x increases, if f of x increases as x increases. As x increases means if you are increasing the value of x, your functional value also increases. For example, if you consider some function like this, 0, x, y, and of course this is minus x and minus y, no matter. And suppose if you take some function like this, you can clearly see whenever x is increasing, this f of x is also increasing, correct? Now, if I consider these points here, x1 and x2, what could be this value? This is f of x1, and this value here could be something similar to f of x2. Now if I calculate this delta y by delta x, means for a given change in x, what could be the corresponding change in y for this function? If you calculate this, what could happen? F of x2 minus f of x1 divided by x2 minus x1, correct? Now if you want to decide the nature of this function at a particular point, see, this is some part of the interval x1 to x2. Now if I want to talk about this function at a particular point, let me write limit x1 tends to x2. Similarly, limit x1 tends to x2, and this is nothing but f dash of x2. Correct? By our definition, this is nothing but f dash of x2, and this is nothing but slope of tangent to this curve drawn at this point x is equal to x2. So let us try to draw one tangent here. If you try to draw one tangent here, let us try to draw one tangent here. So if you try to draw this tangent will be clearly making an angle theta which is less than 90 degrees. Correct? Can you see this? I am talking about the increasing or decreasing nature of this function at the point x is equal to x2, and you can clearly see the tangent at this point C. For example, if you call this C, the tangent to this curve at point C is making an angle theta which is less than 90. And of course, since this is equal to tan theta, and when theta is less than 90, this is positive, which means if a function is increasing at a particular point, then definitely the derivative of that function y is equal to f of x at that particular point will be positive. Okay, which you can see the case like this. So this implies for f of x to be increasing at a point, f dash of x is equal to 0 at that point. It should be greater than 0 at that point. This is what you have seen here. Is this clear to all of you? Did you all understand why for a function to be increasing, its derivative should be positive at a given point? Can you all understand this? Why for a function to be increasing at a given point, its derivative should be positive? Yes or no? Please tell me. All of you, please respond. Whoever is on live. Yes. Now let us talk something about decreasing functions. Good. So let us talk something about decreasing functions. Decreasing functions. Now what is a decreasing function? It's obvious. A function f of x is said to be decreasing function, is said to be a decreasing function, if f of x decreases, as x increases. Okay, let me write complete word better, as x increases. Okay, and now you can see this graphically as well, no matter. This is 0, x, and if this is y, where this is minus x, and if this is minus y, and if you can see a curve something like this, where this is y is equal to f of x, and now if you apply the same analogy which I have applied for earlier functions, if I want to talk about increasing or decreasing nature at this particular point, x is equal to C, for example, then let me draw one tangent to this curve. If I draw one tangent to this curve, then you can see this angle theta is greater than 90. If this angle theta is greater than 90, then you can easily sense, since slope at this point is nothing but tan theta, and theta is greater than 90, means theta is coming into the second quadrant, so tan theta could be negative. Okay, so this is what it can happen. This implies f dash of x has to be less than 0 at a given point, for the function to be decreasing. For the function to be decreasing. Okay, so now you can see clearly here, as x is increasing, your f of x is continuously decreasing, and of course if you draw a tangent at any particular point to this curve, this theta will be greater than 90 and this tan theta is negative, which is mathematically written by this equation. So now if a function is given to you, can you identify whether the function is increasing or decreasing at a particular point? Yes or no? Please tell me. If I give you a function and if I give you a point, and if I ask you whether the function is increasing or decreasing at that particular point, can you tell me? Yes? Yes. Good. Now there are certain kinds of functions. There is something called monotonically increasing functions, and there are few functions which are called monotonically decreasing functions. Let us see. Monotonically increasing functions. Monotonically increasing functions. A function f of x is said to be monotonically increasing. A function f of x is said to be monotonically increasing if f dash of x greater than 0 for all x belongs to R. Means if you take at any point on the real number axis, its derivative will be positive. For example, if you see e power x, the graph looks something like this: minus x, x, y, and minus y. And if you see, the graph appears to be something like this. This is y is equal to e power x, and of course, e power 0 is 1, and this tends to 0 as x tends to minus infinity. Clear? So if you see at any point from minus infinity to infinity, always this function is continuously increasing. So can you identify what is monotonically decreasing function now? Can you all identify what is a monotonically decreasing function? Please respond, all of you. See, mono means single. Correct? Means the function should possess single nature, either increasing or decreasing throughout the complete real number plane. This is the meaning of this. Means the functions are having single nature. Okay, either increasing or decreasing, doesn't matter. Then they are called monotonically increasing or monotonically decreasing functions. So if you talk about monotonically decreasing functions, a function f of x is said to be monotonically decreasing if f of x is decreasing for all x belongs to R. For all x belongs to R means on a complete real number plane, if you keep on increasing the value of x, your f of x keep on decreasing. For example, you can see here 0, x, minus x, y, and minus y. If you see this, if you try to draw the plot of e power minus x, you can get something like this. Okay, and of course this is y is equal to e power minus x, and this is the value of 1 on y axis, because e power minus 0 is same as e power 0. So if you see, this is y is equal to e power minus x, and from minus infinity to plus infinity, if you keep on increasing x, your f of x keep on decreasing. But all the functions need not be of monotonic nature, correct? Because if you see sin x, for example, if you take sin x example, then you can feel the graph of sin x is something like this. For example, if you talk about the interval 0 to 2 pi. Okay, so if you consider this point, which is pi by 2, similarly this is 3 pi by 2, then of course this is equal to x. Now from 0 to pi by 2, this function is increasing. You can see, correct? Yeah. See here, from 0 to pi by 2, as you keep on increasing your x, your f of x is increasing. And from this point, if you keep on increasing your x, this f of x keep on decreasing till this point again. Again from here, if you see, this again increases. So this function is neither monotonically increasing nor monotonically decreasing. So there could be some functions where you need to find within a given point this function is increasing or decreasing. Okay, so of course this is a simple example to say, but sometimes if they give you complicated functions, then you should be in a position to say by differentiating it whether the function is increasing or decreasing. Log x graph, Dilwar, we are talking about log x. Log x to the base a has two different graphs. Okay, and that's why this is one of the reason why it's been asked in exams. One is this, and second is this case. In the first case, the graph looks something like this: 0 to x, y, minus x, minus y, and the graph looks something like this. Of course, it is decreasing. Y is equal to log x to the base a, and this is the case, of course, when 0 is less than a less than 1. Y is equal to log x to the base a, of course 0 less than a less than 1. And similarly, if you try to draw here a greater than 1 case, 0, minus x, y, x, and minus y, whenever your a is greater than 1, you can draw something like this. where this is log x to the base a and a is greater than 1, and this value at x is equal to 1, log 1 is 0 in both the cases. Okay, these are two different graphs. Yeah, these are monotonically increasing. Yeah, we can say sin x is monotonically increasing in the interval 0 to pi by 2. That's fine. But since we are talking about the real number plane, we couldn't use the term monotonically increasing. Okay. So is that clear to all of you about the background of maxima and minima concept and what are increasing and decreasing functions? If that's okay, we'll move on to questions now. Because it's already 25 minutes since we have started. So I hope that could be fine. Correct? Yes. So shall we start questions, all of you? Okay. This is the first question. Try to solve this. As x increases from minus infinity to infinity, means over the complete real number plane, the function f of x is equal to e power x by 1 plus e power x. Try to solve this question. They were asking about monotonically increasing or monotonically decreasing. Then first it increases to a maximum and then decreases. There are 4 different options. Please try to work this out. Okay, I'm moving aside so that you can see the question clearly. So please try to answer this question. It's given, as x increases from minus infinity to infinity, the function f of x is equal to, which is given by this function, some exponential functions. This function is monotonically increasing or monotonically decreasing, or increases to a maximum value and then decreases to a minimum value and then increases. Kamaluddin, it's option A. That's what you are telling. Okay, let's see. And meanwhile, if you are liking the content, please do like and subscribe the channel and share the videos as well, because since we are doing it for free, it could be of help to many others. Okay, so please try to do this. Option A. So let me solve this. What is your f of x? E power x divided by 1 plus e power x. Now, if you want to know the nature of this function, whether it's increasing or decreasing, you should be in a position to calculate its first derivative, correct? So let us calculate. This implies f dash of x is equal to, the formula for differentiation for ratio of two functions, denominator function into derivative of first function, which is e power x, minus numerator function into derivative of denominator function by square of denominator function. This is what we have. Correct? If you multiply this e power x into e power x and this minus e power x into e power x gets cancelled, and this expression will give you something like e power x divided by 1 plus e power x whole square. Now, for any value of x, even for negative in values of x, this e power x is never negative, correct? This is always positive. Or else you can see there is a square here, so denominator is always positive, doesn't matter. And of course, this e power x is never negative because e is some numerical value around 2.71, and positive value power anything always gives you positive value. So this positive divided by positive, this is totally positive. And we didn't put any points, we didn't substitute any value of x at any point here, correct? So which means the function is monotonically increasing because at every value of x, this value is always positive. Clear? Now, did you all understand how to identify monotonically increasing functions and monotonically decreasing functions? So please respond. Did you all understand how to identify monotonically increasing and decreasing functions? Clear? And this question was asked in 2006, but it's a good question, so I put it here. Okay, so this is the next question. For real values of x, the minimum value of the function exp of x is nothing but e power x. Okay, if you write exp of something, this is exponential to the power x. Thank you. You're welcome, Mathematical World ES. Okay, so please try to solve this question. F of x is given something like e power x plus e power minus x. So please try to solve this question. Find the minimum value of this function. Since I have given you the procedure for finding maxima and minima, so please try to find the value of this. Good evening, Kalimullah. So please try to be on time and please try to solve this question, all of you. It's a good question actually. Option A. Always Kamaluddin is first to answer, so I hope others to beat him. Not physically, in the chat box. Okay. Option A. Divya, Kamaluddin. What about others? Still many people are trying to do this. Okay, so let us see. Okay, Umesh, good. So what's the procedure? First of all, if you want to calculate minimum or maximum, you need to find the stationary point. So let us find the stationary point. E power x minus e power minus x is equal to 0. This implies e power x is equal to e power minus x, and this implies you that x should be 0 undoubtedly. Correct? This is the only stationary point which we are getting. So now see here. Let us calculate second derivative to confirm whether this is maximum or minimum. Look, since in the options it's not given that this is a point of inflection, you know, if derivative is 0, then maximum or minimum does not exist. But in the question, it was clearly asked what is the minimum value of the function, and 4 options are given, and in the 4 options there is no option like it's a point of inflection. Correct? So which means definitely at this particular point x is equal to 0, we are getting minimum value of this function. But anyhow, let us check the second derivative also for surety. So if this is first derivative, what could be the second derivative? E power x plus e power minus x, and this implies f double dash of this x naught, which is here, is equal to 2, and this is greater than 0, which means at this point x is equal to 0, this function has minimum, which they are asking here. So minimum value is f of 0, which is equal to e power 0 plus e power minus 0, which is 2, and it's in the first option. Okay, this is what you can do, or else if you know a little point, you can answer this question in 5 to 10 seconds. See here, what is that point? I'm going to tell you. If you might have known this point since you are schooling, if a comma b are two positive values, are two positive real numbers, then you might have studied this. Arithmetic mean will be greater than or equal to geometric mean. Have you studied this? Do you know this point? If these are two positive real numbers, then definitely the arithmetic mean of those two numbers will be definitely either greater than or equal to the geometric mean. I have also proven this am greater than or equal to gm condition in the basic course. Again, you can go there for if you want the proof of this, but I hope many of you know this. Okay, since we are revising, I am going a bit quick. Is that okay to all of you? Do you all know this? And what is arithmetic mean? A plus b by 2. And what is geometric mean? Square root of ab. This will be always greater than this. Now, if you take these two functions, e power x and e power minus x, both these are positive values for any value of x, correct? You know, these exponential functions will never be negative, correct? So if you apply these two functions here, we can get e power x plus e power minus x by 2 is always greater than or equal to square root of e power x into e power minus x. And you know, the value of this is 1. So e power x plus e power minus x by 2 is always greater than or equal to 1, which is also same as e power x plus e power minus x greater than or equal to 2. If this function is always greater than or equal to 2, then the minimum value is 2. Correct? Because we are clearly telling this value is always either 2 or it's greater than 2. If this is either 2 or greater than 2, then the minimum value will be definitely 2. If you know this point, you can write this step directly, which is single, you know, just one step here. Clear? Did you all understand this logic? So how x is equal to 0? Okay, Shabin, look here. If I shift this e power minus x to the left hand side, Shabin, I am telling for you, so please respond. If this is e power x and this is e power minus x, can I write this as e power 2x is equal to 1 here? Can you write this? Shabin, please respond. Can you write this? E power 2x is equal to 1 if you shift this e power minus x to the left hand side? Yes, if you can shift, then you know something, logarithm, basic property of logarithm. If a power x is equal to n, then x is equal to log n to the base a. You know this, correct? So here you have e power 2x is equal to 1. This implies 2x is equal to log 1 to the base e, which means log 1 to any base is 0. So 2x is equal to 0 and x is equal to 0. Okay? I hope you understood now. So this is the next question. So please try to solve this. It was asked in 2011 for triple E. So please try to solve here. I'm going a bit quick. Please don't worry for this because it's a revision class and I need to maintain this pace. Otherwise, things won't get finished by time. Clear? So we need to be a bit faster, of course. And that's why I'm revealing you the topic that I'm going to discuss in the next class, in previous class itself. So that if you have some time, you'll be working on the theory lecture in previous course corresponding to that topic and you'll come here. Okay. Option C, Divya. Option C, Kamluddin. Nagendran, C. What about others? C, Mauli, Suhas. Okay. So see here. First of all, I will say these two options are wrong. Can you tell me why? By looking at the question itself, I will tell you that these two options are wrong. Can you tell me why? Can anyone tell me why? By looking at the question, if I say that first two options are wrong, can you tell me why? Yes, because this function is quadratic function. So if you differentiate, you will get only one stationary point. And this maximums and minimums will occur at stationary points, which means for both maximum and minimum to exist, it should have minimum two stationary points. Correct? But if you see, there is only one stationary point for this function. So these two options are wrong. Next, now let us work out. What is f dash of x? 2 minus 2x is equal to 0. So this implies x is equal to 1. And f double dash of x, if you calculate, derivative of this is minus 2, which is less than 0, which means this function f of x has maximum at this x is equal to 1. That's it. Clear? It was asked in 2011 for triple E people. Is that clear to all of you? Fine. It's a very simple question. You can solve this easily. I told you if second derivative at this point, at any point its second derivative is less than 0. So of course the function is having this. Fine. Look at this question. A political party orders an arch for the entrance to the ground in which annual convention is being held. The profile of the arch follows the equation of y is equal to 2x minus 0.1 x square. It's quite common. We make parabolic arches where y is the height of the arch in meters, the maximum possible height of the arch. If this is the equation to be followed. Yeah, from tomorrow we are starting integral calculus. Actually, in my schedule I have given one cumulative session, but because we lost one class, so I thought of having the whole cumulative after the completion of basic calculus. Okay, so we'll be having cumulative 1 in place of cumulative 2. And from tomorrow we are starting this integral calculus anyhow of single variable. Of course, once if single variable is done, we'll step into multivariables. Then partial differentiation and all comes into picture. 10 is the answer, Divya. Good. Shabin, good. 10 is the answer. Mauli, fine. Okay. Correct. 10 is the answer. So see here. If this is the ground, then these people are ordering an arch, which is parabolic. Okay. And it is given something like, if this is x-axis from here, the arch is something like this. Height of the arch. Of course, it's given y. And this is h max of the arch. And people will be walking inside to this arch. Okay. And the equation of this arch is given by y is equal to 2x minus 0.1 x square. So if you want the function y is equal to 2x minus 0.1 x square. So if you want y to be maximum, this implies dy by dx is equal to 0 for y max. Dy by dx is equal to 0, which means 2 minus 0.1 into 2x has to be 0. Correct? And this implies 2 is equal to 0.2x. So x is equal to 10 meters, which means at a distance of x is equal to 10 meters, we are having the maximum height of the arch. So if you put x is equal to 10 in this equation, you will be getting y value also 10. 20 minus 0.1, yeah, correct. 20 minus 0.1 into 10 square, which is 10. Y max, of course. This is a simple question. You can. 10 is the answer. So see here. If this is the ground, then this people are ordering an arch, which is parabolic. Okay. And it is given something like, if this is x-axis from here, the arch is something like this. Height of the arch. Of course, it's given y is equal to 2x minus 0.1 x square. So if you want the function y is equal to 2x minus 0.1 x square. So if you want y to be maximum, this equation is given by y is equal to 2x minus 0.1 x square. So if you want the function y is equal to 2x minus 0.1 x square, so x is equal to 10. If limit was given, then for finding length, we should integrate. We have that how to find length of some curves for which geometry is not that much defined. We'll do that in applications of integration, which I have put already as one lecture in this course. Okay, maybe we may talk about that in coming 2-3 lectures. Okay. No, group theory we're not dealing at this moment. So fine. Is that okay with this question to all of you? Can I go for the next question? What is meaning of arch, Akshay? This is arch. You know, whenever you enter any function, there will be some parabolic shaped setting over there. Correct? You will be walking through this into the hall. That's what you call an arch generally. People will be walking something like this inside. Okay. So this is the question. So please try to solve this. Please try to solve this question, all of you. And if things are going fine, you please like the video anyhow and share it. And also you can subscribe to the channel for getting further notifications whenever we are, planning some lectures, or if we are introducing some courses, you'll get to know of that and you'll be able to follow it from the first lecture itself. Okay. So better if you subscribe the channel if you are here for the first time. Let f of x is equal to x into e power minus x, then the maximum value of the function in the interval 0 to infinity, means basically x is greater than 0. Option A, Kamaluddin. See, the function is x into e power minus x, and the minimum value, the maximum value of the function is within the interval 0 to infinity. Mauli, you two got option A. Okay, so let me try to solve. It was again asked in 2014 for triply. So see here, f of x is x into e power minus x. So what could be f dash of x? X into minus of e power minus x plus e power minus x into 1. And this implies e power minus x into 1 minus x. This should be 0. Correct? Now, within the finite values of x, this will be never 0, of course. So the thing that has to be 0 is x minus 1 has to be 0 and x is equal to 1. Because, there is nothing called at x is equal to infinity, this function will tend to 0. And of course, this is an open interval. So x is equal to 1 is the value where we are having a stationary point. So if you calculate, of course, if you go for the second derivative, definitely you will be getting less than 0 because options are given and there is nothing like point of inflection in the options. So you can calculate f of 1 directly. If you calculate f of 1 into e power minus 1. So e power minus 1 is the answer, which is here. Clear? But if in the options, if there is something like point of inflection, then definitely you should go for the second derivative test. Okay. Since here, there's nothing like point of inflection in the options, then I'm straight away going for, I have got only one stationary point. So I know that this maximum definitely occurs at this stationary point. If it's not that case, then you need to go for second derivative test as well. Okay. Is that clear to all of you? Yeah, I'm happy. All of you answered it correctly. So can I go ahead? Please say yes or no. Okay. And if you have any doubts in between, I'm at most happy to answer you. Okay. So you please ask me if you don't understand something or if something is not going fine. This is a very good question. Try to solve this. The best approximation of the minimum value attained by e power minus x into sine of 100x for x greater than 0. This is a very good question. I would like to start a timer for this, if you would like to do it. So please try to answer this question. There is 6 seconds lag between my teaching and your video. I could see it now. So please try to answer this question. It's a really good question and put your efforts and try to solve this. No, 0 is wrong answer. You're welcome, mathematical world. No, 0 is wrong. I'm telling you, 0 is wrong answer. Okay, 0 is wrong answer. Please try. It's a very good question. I'm telling you, minimum value of sine is not 0. Okay, it's -1. So you can go for that. Even if x is greater than 0, sine can be still negative. Okay, because from pi to 2 pi sine will be negative, and pi to 2 pi is positive values of x where you have sine as negative. 0.982 Kamaluddin. No, I guess. No, definitely no. Pi by 2 is wrong. Pi by 2 is wrong. 0.982 is wrong. This question was from 2014 mechanical. Okay, 9.9944. No, wrong. I'm very much happy if you are telling wrong answers. Okay, because if you want to learn something, you need to commit some mistakes. No, 0.99 is also wrong. I'll wait for 3 minutes. Okay, because in GATE exam that's the time you have for solving any question. So 0.98 wrong. 0.982 wrong. 0.98 wrong. Yeah, definitely wrong. Last 40 seconds. Come on, please try. Let's see who will be the first. Okay, last 30 seconds. 0.984 wrong. Umesh, 0.98, 0.984, all these are wrong. 45 degrees. See, oh my god, whatever I'm asking about minimum value of the function here. Dilavar, so please. See, 3 minutes is going on. No one is about to answer. I'm revealing the solution. Last 10 seconds. 9, 8, 7, 6, 5. Raghavi, yes, correct. It will be in negative. I agree. Good. Answer is negative. Yes. Dot. Sorry, no. None of you answered it. Okay. So let me try to solve this. If you look at my first, okay, whoever didn't attend my last course, please try to learn. Also in this course, I have given some introduction. If you want to, learn how to draw a graph of any function, the first basic step is set up an axis. 0, x, minus x, y, minus y. Correct? Then I told you to calculate the maximum and minimum values of this function if possible. Correct? Now tell me one thing. Whenever x is greater than 0, minus 1 less than or equal to sine 100x less than or equal to 1. Will you all agree with me with this point? Of course, when x is greater than 0 or less than 0 doesn't matter. This sign will always, sign of something will always lie in between minus 1 and 1. Is that clear so far? Is that clear so far? Yes. Now let us multiply this inequality with e power minus x. Minus e power minus x less than or equal to e power minus x into sine 100 of x less than or equal to e power minus x. Please don't confuse between this minus x here and this. Okay, this is this axis notation. Okay, so will you all agree with me if I multiply with e power minus x, because e power minus x is never negative, it's a positive, so I can retain this inequalities as it is. I need not change these inequalities. Correct? Because e power minus x is always positive for any value of x, and of course it's given x greater than 0. Correct? Can you all agree with me till this point? This is very good question, and that's why none of you are able to answer this actually. Okay, so I am revealing the solution. Clear? Now see carefully. Means whatever the graph you draw for this function e power minus x into sine of 100x, that graph should definitely lie in between minus e power minus x and plus e power minus x. Now if you try to draw, e power minus x is something like this, and minus e power minus x is something like this. Can you all see this? This is y is equal to e power minus x, and since this is of negative values, this is y is equal to e power minus x. Minus e power minus x actually. Can you all feel this? Now, whatever graph you draw, you should draw in between these two white curves. Yes or no? Because your inequality is clearly telling this function should lie between these two. Yes or no? Now, since magnitude is controlled by these functions, the graph will look for the shape of this sin x. So, if you want to try to draw, you can draw. The graph looks something like this. Sin x inside this. Correct? This is how the graph of e power minus x into sin of 100x look like. Did you all understand how to draw the graph clearly? First of all, after setting up the axis, you need to know what are the boundaries for this graph. And once you know the boundaries, then you know magnitude is controlled by this function and shape is controlled by this function. So if you see, this is how the graph looks, which means one thing is very clear. You will be getting the minimum of the function at this point. Clear? Because as you keep on increasing x, this e power minus x will rise to the top, which is close to x-axis, which means the minimum of this function will occur at this point a. Is that clear to all of you till this point? Can you all understand that the minimum of this function will occur at x is equal to a, corresponding to this point? Yes. And what is this value of x? I mean, if we are drawing for 100x, because this is sin of 100x into e power minus x. So if you are drawing this value, means 100x we are drawing, this 100x value at this point is equal to 3 pi by 2. Correct? Did you all understand why did I write this? Because this is not sin x graph, this is sin of 100x graph. So this 100x should be equal to this 3 pi by 2. Clear? Did you all understand this equation? If you understand this equation, that's it. Question is done. Can you all understand this equation? I want all of you to respond. Please respond. Yes? Now, what's the value of x? X is equal to 3 pi by 200, and of course this is in radians. This is the point where this function will be having minimum value, and that is what you want. So if you put x is equal to this value in that function, we can get, therefore, f of x minimum is equal to e power minus 3 pi by 200 into sin 100x value is 3 pi by 2 anyhow, so 3 pi by 2, and this value is minus 1, of course you know this. So this is minus of e power minus 3 pi by 200. Okay, let us calculate this value. How did I get 3 pi by 2? Because for this sine curve, you will be getting the minimum value of sine in the first part, as the negative value. See, for example, if you are drawing sin x graph, you will be getting something like this, and this value of minus 1 occurs at x is equal to 3 pi by 2, correct? And this is the same thing which happens here, and this value, since we are not drawing sin x, it's sin 100x graph, so 100x value should be 3 pi by 2 at this point. In order, the sine should have minimum minus 1 value. Of course, it's not minus 1, but to have the minimum at this point. Clear? So if you calculate this value, e power minus 3 pi by 200, look, I am going to use a virtual calculator here. E power minus 3 pi by 200. Let us calculate the value of minus 3 into pi by 200. And you want the exponential of this. This is what you have, but we have a minus sign before that, so we'll change the sign. Minus 0.954 around is the answer. So minus 0.954 is the answer for this. Clear? Imran, did you understand why 100x is equal to 3 pi by 2 but not x is equal to 3 pi by 2? This question is really a good question which came in 2014 for mechanical actually. Most tough and concept question, sir. No, actually if you know how to identify the graphs, it's done. It's a simple question. It was asked in mechanical, and there could be equal chance that it would be asked for ECE as well, because you deal with vibrations and signals, which in vibrations, if you see damping, this is how it happens. Have you seen this equation? X is equal to a into sine omega t, something like this. Some magnitude into sine of some function, vibrations and all. 12th class physics or 11th class physics maybe. Yes? Yeah, oscillations and all. Correct. So answer is 0.954. Of course, you can see 0.9 minus 0.954 in the PDF that I send you. So this is a good question. Okay, so can we go for next question now? I hope things are clear. So please go for this question, since we have further some more questions to do. So meanwhile, you try to solve this question. Meanwhile, I'll be having some water. In this, they are asking the maximum value of the function occurs at, and they are given options. Now tell me one thing, do you need to find the stationary point at which it is maximum, or you need to find the maximum value of the function? Tell me what to find. Do you need to find the point or function value? Please tell me. We need to find point, correct? Stationary point basically. So good, Divya, I hope it's log 4. So let us solve. 0 less than or equal to t less than infinity. Okay, fine. What is the function given? F of t is equal to e power minus t minus 2 into e power minus 2t. If you calculate f dash of t, this is equal to derivative of this e power minus t is minus e power minus t, and derivative of this is plus 4 into e power minus 2t. And if you equate this to 0, this implies 4 e power minus 2t is equal to e power minus t. And of course, within finite values of t, this won't be equal to 0. So you can cancel 1 e power minus t here. So you can have e power minus t. So 4 into e power minus t is equal to 1, and which implies e power minus t is equal to 1. Yeah, 1 by 4. This implies minus t is equal to ln 1 by 4, which can also be written as minus ln 4. And ln is nothing but log 4 to the base e. You can cancel this minus signs, and t is equal to ln 4, which can also be written as log 4 to the base e. And normally you need to go for a second derivative test, then you need to substitute this point, and you need to know whether the stationary point at the second derivative is less than 0 or not. But since when should log and ln take? Both are same if you write e. See, these two are same. Okay, log to the base e or ln, both are same. But if they write something like this, log 4 without any base, this means this is a natural logarithm. Okay, so you should be taking care if there is nothing like this but log is written. But if ln is written, you can go for base e. Okay, so this is log 4 to the base e. But since in the options, we have log 4 to the base e, and we are not getting any stationary point, any other stationary point, then you can feel the maximum comes at only this stationary point, and we can go for option A straight away. Clear to all of you? Is that okay to all of you? Yes, it's an easy question. Basically finding the stationary point. Okay, they are not asking for the maximum value of the function, but they are asking the point of x at where this function reaches maximum. Yeah, this is a quite easy question. It was asked in GATE 2015. Yet, so please try to answer this while minimizing the function. They are opting to minimize. Okay, Shabin, if you want to calculate the maximum value for previous question, how you need to do? You got the stationary point, so put t is equal to log 4 in this function. If you put f of t maximum is equal to e power minus log 4 to the base e minus 2 into e power minus 2 log 4 to the base e. This is equal to, 4 power minus 1 minus 2 into 4 power minus 2. This is 1 by 4 minus 2 into 1 by 4 square, which is 16, which is 8. So 1 by 4 minus 1 by 8. I hope 1 by 8 is the answer, maximum value. Okay. D is the answer, because if you want to minimize any function, then definitely the second derivative first derivative has to be 0. So these two are wrong. So when first derivative is 0, for the function to have this minimizing at this point x is equal to x naught, its second derivative should be greater than 0. So option D. Oh, yeah, option D is correct answer. Okay. Yeah, it's a simple definition which we gave in the beginning of the class. Oh, okay, fine. This is the question. This is also some good question. So please try to answer. It was given in 2015 for ECE. Which one of the following graphs describes the function f of x is equal to e power minus x into x square plus x plus 1? So there are 4 graphs given. Now out of these 4 graphs, which is the graph corresponding to this function? It was asked in 2015 for ECE. So please answer this. See, whoever attended my class already, in that class I have discussed few previous gate problems, but please don't answer directly. Try to do it once again. Okay. I know that I have already covered this question in that course, but still I request you to do it again so that you'll get handy with all the questions. And I'm telling you again, if you're liking the content that's being shared here, you can always like the channel and like the videos, and you can write something in the comment box, some good feedback, or if you want some modifications, you can write it there. I'll be happy to learn from you. Okay. Which one of the following graphs describes the function f of x is equal to e power minus x into x square plus x plus 1? Now tell me how to do this. Look, I'll be helping you out. See here. First of all, let us find whether this function is increasing or decreasing or some other things. Okay. So f of x is equal to e power minus x into x square plus x plus 1. So let us calculate the first derivative of this. This implies f dash of x is equal to e power minus x into differentiation of this function is 2x plus 1 plus second function x square plus x plus 1 into the derivative of first function is minus e power minus x. This is what you can write. So if you simplify the things a bit, f dash of x is equal to option D, because second derivative is positive. Muhammad Anish, okay, let us see. Lokesh, it's D, okay, let us see. If this is e power minus x, if you take e power minus x common, you have 2x plus 1. Because of this minus sign involved here, we write minus x square minus x minus 1. This is what we can write. This 1 and minus 1 gets cancelled. So f dash of x is equal to e power minus x into 2x minus x square minus x. This 2x minus x will give you x minus x square. This is what you have. Correct? Now tell me one thing. For 0 less than x less than 1, x square is less than x. Correct? Will you agree with me if I say this? For 0 less than x less than 1, this x square will be less than x. Correct? Yes or no? Please respond. All of you, please respond. Yes? First of all, tell me whether this happens or no. If x is lying in between 0 and 1, your x square will be less than x. If x square is less than x, this implies x minus x square is positive. Correct? Can you all feel this? If x square is less than x, then definitely this x minus x square has to be positive. If this is positive, what could be this e power minus x? This e power minus x is always positive, independent of the value of x. Whether x is lying in between 0 and 1, or it's negative or it's positive, it doesn't matter. This e power minus x is always positive, which means, can I tell for 0 less than x less than 1, f of x is increasing? Is increasing? Can you tell this? Please tell me. For f of x, for 0 less than x less than 1, this f of x is increasing. Can I say this, and will you all agree with me with this point because of this particular analysis here? Please respond, all of you. Whoever is on live, please respond. Correct? Can you all agree with me? Now if you see, means out of all these 4 graphs, the graph which is immediately to the left of this y axis should be increasing. Correct? because 0 to 1, 0 less than x less than 1, this means x is lying in between 0 and 1, which means x value on x-axis is quite to the left of this, means somewhere here. These values of x, which are here. Correct? At these values which we have done, the function this f of x has to be increasing, which is only present in this option B. You can see the function is slightly increasing to some value. But in all these three cases, f of x is decreasing from 0 to the immediate right. So all these three are wrong. And B is the correct answer. Can you all understand this? This is why the concept of this increasing and decreasing functions is important. And this question was asked in GATE recently, 5 years back. Okay. So did you all understand this? Why it's option B? Clear to all of you? Yes or no? Please respond, all of you. You know, I can't see your faces. It's an online class. So please better respond. Okay. And if you are writing the wrong answers, no one is going to put you in jail. Okay. So you can always type something that you get. Did you all understand the logic? Why this question is opting for this option? Okay, so we'll go for next question. Yeah, this is the question. So please try to solve this. The maximum area in square units, of course, area is always in square units, of a rectangle whose vertices lie on the ellipse x square plus 4y square is equal to 1. You know, in ellipse, these two won't be the same, so it's different. So you can clearly identify this is an ellipse equation, and there is a rectangle inside this ellipse. So better you find what the maximum area possible. So please try to do this question. It's a good question actually. Again, it came in 2015. The maximum area in square units of a rectangle whose vertices lie on the ellipse x square plus 4y square is equal to 1. Whoever is on live, please genuinely try all the questions. It doesn't matter whether you get answers or you don't get them, but at least you should attempt it. Okay, because to be honest, I know the solution of this question. Okay, I'll be able to solve this, but I don't want that. I want you to solve that question. Okay, so please try something. It doesn't matter even if you don't get the answer. Answer is 2. Is it? Kamluddin and Mowli, both of you gave the same answers. 2. Umesh, 2. But for me, it's appearing like answer is something different. Looking at the top of something visible here, you know, in this small area. Okay, so shall we solve this? Because it's, you know, you're taking a bit of time. Or else I'll give you some more time, 1 more minute. You please try this and tell me the answer. What's the maximum area in square units of a rectangle whose vertices of the rectangle lie on the ellipse? 1/4 Dilavar? Okay, let me check. You know, let me try to draw an ellipse. Origin, x-axis minus x, y and minus y. Okay, so now you have, you know, one ellipse. So let us try to draw one ellipse somewhere equidistant here. I hope this is looking like an ellipse, but something similar to egg, correct? Oh, I am a very bad artist, so please forgive me for my bad drawings. Now I think it's looking like something ellipse. Okay, now there is one rectangle inside this. One rectangle is sitting inside this. Okay, there is one rectangle also in this. Now, depending upon this, you know, you can shrink this rectangle such that its breadth increases but length decreases. So there can be infinitely many combinations of these rectangles that can happen here. Now, if you want the rectangle area to be maximum, what is the maximum possible area? Let us do this. Let us assume the length of the rectangle is 2a and the breadth of the rectangle is 2b. Okay, and this 2a and 2b are variables, of course, but of course they are dependent because of this equation. So if you see, there can be infinite combinations of rectangles that are possible. Now, what is the area of rectangle for the combination we choose? Area of rectangle is equal to 4AB. 4AB. Now, because 2A into 2B is 4AB. Now, tell me one thing very clearly. If this length is 2A, what could be this length? Will it be A? Yes or no? Similarly, will this breadth be B? Can you tell me this? If this is A and if this is B, what is this point capital A? Can you tell me the coordinates of this point capital A here? If this is A and if this is B, can you please tell me that? All of you, please respond. Can you tell me what are the coordinates of this capital point capital A comma B? Now this point capital A is lying on this ellipse, which means this point capital A should satisfy this equation, which means we have, if A comma B is satisfying this equation, we have A square plus 4B square is equal to 1. So which means from here, since we are dealing in the first quadrant, you can always write, A is equal to square, or else you can write maybe something like B is equal to, or B square is equal to 1 minus A square divided by 4. So which means B is equal to 1 by 2 into square root of 1 minus A square. Can I write this from this equation? Now, if I write this, I can substitute B in terms of A. Therefore, area is equal to, of rectangle is equal to 4 times of A into B, which is 1 by 2 into square root of 1 minus A square. Now this cancels this. So we have something like, oh, it didn't get touched. Okay. So we have area is equal to 2A into root of 1 minus A square. This is the area in combination of any rectangle. Now, if you want to maximize this function, what you need to do? You need to find the maximum value of this function. Let us find the maximum value of this function. 2 times of A into square root of 1 minus A square. Please try to find the maximum value of this function, all of you. I gave you the hint. It's a single variable function, and you know how to find maximum value of a single variable function. So you can find. So please try to find this. All of you, please try to respond. Try to find the maximum value of this function because it's a single variable function. Actually, the area is depending on 2 variables, x, A and B. But to relate A with B, it was given the points, the vertices of the rectangle are lying on ellipse. So we can convert one variable in terms of another, and we can convert total area in terms of a single variable function. So please try to solve this. Okay. BVR SR3 something. So you please look at this. Answer is 0, 1, 0.5. People are telling different answers, so let me solve. Therefore, for area to be maximum, it's a single variable function. So let us differentiate. D by dA of 2A into root of 1 minus A square has to be 0. So let us do this. Of course, this 2 is a constant, so we are cancelling this here. A into derivative of this is 1 by 2 root of 1 minus A square into the derivative of 1 minus A square is minus 2A plus root of 1 minus A square into 1, because when you differentiate this A with respect to A, you will be getting 1. So this should be 0. So if you simplify the things, 2 gets cancelled. Minus A square divided by root of 1 minus A square plus root of 1 minus A square is equal to 0. So if you simplify the things, you have minus A square plus 1 minus A square is equal to 0. Of course, we have a denominator here, root of 1 minus A square, but of course, numerator has to be 0. So if you simplify this, 1 minus 2A square is equal to 0. 1 is equal to 2A square. So this implies A is equal to 1 by root 2. Since we are dealing in first quadrant, we can take this. And what is the area now? area max is equal to 2 times of a, and the maximum value of a, I mean the value of a for which this area is maximum is 1 by root 2. So 1 by root 2 into square root of 1 minus 1 by 2, which is again 1 by root 2. So if you cancel the things, you will be getting 1 as the maximum area for this. Okay, 1 is the correct answer, all of you. Kamruddin, Muhammad Hani, Anish, and all. Okay, so please note this, 1 is the correct answer for this. So can I go ahead? Sorry. Yeah, this is the question. So please try to solve this. As x varies from -1 to 3, okay, which one of the following describes the behavior of the function f of x is equal to x cube minus 3x square plus 1? This is also some good question. Yeah, you can go for parametric coordinates always, no issues. But you don't know what is the exact location of theta for which this area of x, you can differentiate in terms of theta and you can get the answer, Mauli, no issues. Okay. Okay, you want me to move side? Okay, this is GATE 2016 when IISc has organized. C, A. C, B. Okay, then D. Someone please type D. Let's have uniformity of the options. Suhas, Lokesh, Dilawar, Kamaluddin. What about others? Acha, Divya, finally you typed D. So there is a fight between all the 4 options. Okay, so let me tell who is the winner. So see here. What is this f of x? X cube minus 3x square plus 1. Correct? So this implies Kalyani A, Mauli D. Okay, let me see what's the correct answer. Yeah, what is f dash of x? 3x square minus 6x. Correct? Now, if you equate this to 0, you will be getting, if you equate this to 0, you will be getting x is equal to 0 or x is equal to 2. And both these points lie here within this interval. Correct? Now, what is f double dash of x? 6x minus 6. Okay, so this implies f double dash of this stationary point 0 is minus 6, which is less than 0, and f double dash of 2 is 12 minus 6, which is 6. Of course, this is greater than 0, which means, can you tell one thing? F of x has maximum at x 0, maximum at x is equal to 0, and minimum at x is equal to 2. Can you tell these 2 points? Can you summarize this from the second derivative test? Please say yes or no. Can you summarize this derivative test here? All of you, please respond. Can you summarize this from the second derivative test? Yes. Now let us try to plot the graph. This is -1, 0, maybe 1, 2, 3 somewhere here, doesn't matter. So see here. See here. Now f of x has maximum at x is equal to 0. So this is the line corresponding to x is equal to 0, the y-axis, and here we are telling that we have some maximum value. And also we are telling minimum at x is equal to 2. We are having some minimum value. Either, I don't know whether it's on the top or bottom, but let us suppose somewhere. Okay, maybe somewhere here. Now, tell me one thing. Within the interval -1 to 3, if you have this point 3, if you have minimum here and if you have maximum here, tell me one thing. if you have maximum here, should the function look something like this and then decrease? Should the function come like this to minimum and again increase? Yes or no? Because I think the graph is not looking, something good. Should the graph look something like this? Yes or no? Because if this is having maximum here, then definitely to the left it should be increasing and to the right it should be decreasing to have the maximum here. Similarly, to have the minimum here, on the left it should be decreasing and on the right it should be increasing again. Can you understand these 2 points? If it has to have maximum and minimums here, definitely here to this point, to the left of this point, the function should be increasing, and to the right of this point, the function should be decreasing. Similarly, if you are having minimum here, to the left of this point, the function should be decreasing, and to the right, the function has to be increasing. Which means within this interval -1 to 3, the function increases, then decreases, and again increases. So the function initially increases, then decreases, and again increases. So this is option B. Clear to all of you? Did you all understand the logic behind this? It's a very good logic, because if you want to have maximum and minimum, how does the function look like? And how to find maximum and minimum means the points at which the function has maximum or minimum. So it's a concept of maximum and minimum and also graphs. Of course, this is a common class 11, class 12 basic kind of points, but with the help of this you can answer this. Clear? Did you all understand this point? Did you all understand this point? Please respond. Whoever is on live. Okay, so fine. And for notes of this class, and after every class we will be uploading the notes on the Telegram channel, for which we are getting the links in the chat box, so you can click the links and join the Telegram channel. You better subscribe that so you can get the notes of everything. Okay, so this is the next question, so please try to solve. This is also some good question. Option B, Anish, for this, I think no. It was asked in production engineering, GATE 2016. So please try to answer this. The range of values of k for which the function f of x is equal to k square minus 4x square plus 6x cube plus 8x power 4 has a local minima at the point x is equal to 0. So the point is also given at x is equal to 0. This function has to be minimum. Maximum. So please tell me what's the answer for this. It's a really good question, and of course a simple question as well. Option B, no, wrong. So please try to answer this. It's a really simple question that you can answer. And meanwhile, for getting daily updates, you can like and subscribe this video. You can like the video and subscribe the channel. And if you want your friends to get benefited because of these classes, you can always, share the video to them. Okay. Because since GATE is too short, so we thought of offering this course for free. Otherwise, things could have been in a different way. Okay. Which many of you might know already. C is the answer? Yeah, correct. Good, Lokesh. C is the correct answer actually. So let us try to solve this. What is f of x? K square minus 4 into x square plus 6x cube plus 8x power 4. Correct? Now what is f dash of x? K square minus 4 into 2x plus 18x square plus 32x cube. Correct? Let us calculate the second derivative also. If you calculate second derivative, you have 2 into k square minus 4 plus 36x plus 96x square. This is what you have. Correct? Now, if you want to have local maxima at the point x is equal to 0, first of all, f dash of 0 should be 0 and f double dash of 0 should be less than 0. Correct? Will you all agree with me? Because in the question it's given, definitely this function should have a local maxima at the point x is equal to 0. If this function has to have local maxima at point x is equal to 0, then definitely these two conditions should hold good. Correct? And of course, first condition, it holds good because if you substitute x is equal to 0, this complete equation is 0. So this condition definitely holds good. So now for this to have maximum, second condition should hold good, which means f double dash of 0, which is, here there is no 0 in this term, so 2 into k square minus 4. I mean there is no x in this term, so when you substitute 0, this term remains as it is, but both these terms will go to 0 because they have x in each. So if you substitute 0 in place of x, these two terms will go to 0, but this has to be less than 0, correct? Which implies k square minus 4 has to be less than 0. If k square minus 4 has to be less than 0, this means minus 2 less than k less than 2. Which C. Okay? I hope you know how to solve inequality. Okay, if there is something like this, x minus a into x minus b less than 0. If you factorize this and if you get this, then this implies your a should be less than x less than b. Similarly, if you have x minus a into x minus b greater than 0, then your x should be either less than a or your x should be either greater than b. One of these two things should happen. So since here, if you factorize this k square minus 4, you will be getting k minus 2 into k plus 2, which is less than 0. So your k should lie in between minus 2 and 2. Okay, which is that clear to all of you? Did you all understand this question? It's a simple question actually. There's no big problem in this. It's a simple thing. Is the video clear to all of you? Because in my defense, I'm getting some blur here. So is the video and audio clear to all of you? Please respond. Is the video and audio clear to all of you? Sometimes getting blurred. Okay. Because for me, it's completely blurred here. Okay. Video getting blurred. Okay, fine. Audio is clear, video is clear. Okay, fine. So we'll go for next question. This is one good question. Please try to solve this. Good. So please try to solve this question. It's a really good question. Which one of the following is not a correct statement? Please identify this not here. Okay. It was asked in 2019 for civil. So please try to answer this question. Which one of the following is not a correct statement? And I want to introduce one very important point to you. There is some difference between global minimas and local minimas. Okay, which we'll talk after the completion of these questions. Okay, because you need to identify the difference between these 2 points very importantly. Otherwise, there is a chance that you will be losing some marks in your exam. If they ask for local minima, you might be writing global maximas and all. Okay. Especially in numerical answer type questions, they can put you into trap. So we'll talk about that once we finish these questions. Okay. Fine. So please try to answer this. Which of the following is not a correct statement? Can you all feel the function mod x has a global minima at x is equal to 0? Yes or no? Because you know minimum value of mod x is at x is equal to 0. Please read the options. Blurred. Okay. The function x root of x means x power 1 by x basically, where x is greater than 0 has global maxima at x is equal to e. Second option is the function x power 1 by x, of course when x is greater than 0 has global minima at x is equal to e. Third option is the function x cubed has neither global minima nor global maxima. Option D, the function mod x has the global minima at x is equal to 0. So these are the 4 options. So you please try to tell the answer for this question. Please try to answer this question, all of you. It's a very good question. Option B is the wrong answer. Okay, so let me check. First of all, these two statements are correct. Yes or no? We know this because the function mod x has global minima at x is equal to 0. Of course, on the complete real number plane, mod x has least value at x is equal to 0. Next, the function x cube has neither global minima nor global maxima. Correct, because we don't have any finite defined values of maxima and minima for x cube. As we keep on increasing x, your x cube keep on increasing. Similarly, as you keep on decreasing your x cube keep on decreasing. So there are no finite global minimas and maximas. Correct. Now we need to identify at x is equal to e, this function has global maxima or global minima. First of all, let us calculate the first derivative. If this is f of x, f dash of x is equal to, see carefully. If you want to differentiate this function, how to differentiate? I'll tell you, because many of you might got stuck at this point. So see here. Whenever there is power forms, x power 1 by x, x power x, x power minus x, and all these things, let y is equal to x power 1 by x. So apply logarithm. Log y to the base e is equal to, if you apply logarithm, this is on power to this x. So this will be 1 by x into log x to the base e. And if you differentiate this, 1 by y into dy by dx is equal to, if you differentiate this product of two functions, you have first function into derivative of second function plus second function into derivative of first function. This implies dy by dx is equal to, or f dash of x is equal to, see, I just wanted to show you that stationary point is x is equal to e. That's why I'm going to do this. So y into means y is x power 1 by x. So x power 1 by x into, this is 1 by x square minus log x by x square. So 1 minus log x to the base e by x square. This is what you have. Now, for this function to have either maximum or minimum, this has to be 0. And if x is positive, this value will never be 0. Correct? If x is positive, this value is always positive. So this is number 0, which means this numerator here has to be 0. This implies 1 minus log x to the base e is equal to 0, which means x is equal to e. So x is stationary point. This is what you can feel. Now, if x is stationary point, normally if you want to find whether this function is either maximum or minimum to this given function, means this is the point of maximum or minimum to this given function, you need to calculate the second derivative and you need to calculate the second derivative value at x is equal to e. But that is so time taking, because finding second derivative of this function means basically differentiating this function is not that easy. Correct? Now let us use some senses here. Look, x is equal to e is stationary point. Correct? Stationary point. This is what means either maximum or minimum should happen here, definitely. Now one point is, let us calculate e power 1 by e, and value of e is 2.71 something. So let us also calculate 4 power 1 by 4, which is towards the right side of the axis. Let us calculate these two values using a calculator, because in gate examination we have the axis of calculator. Correct? So if this is x and if this is x power 1 by x, definitely at this point either maximum or minimum occurs where at x is equal to e. Now let us also calculate the functional value on the line x is equal to 4, and this is y is equal to x power 1 by x. Let us take calculator and let us calculate. E power 1 by e, the value is 1.4, which means this value is 1.4. Okay, now let us calculate the value at x is equal to 4. 4 power 1 by 4. If you see, this is 1.414. Correct? So this is at x is equal to 4. This is 1.414. Now tell me one thing. This is the most important observation here, because finding derivative is really tough for this question. So let us take the help of a calculator and let us sort it out. See carefully. At x is equal to e, your value is 1.4. Having minimum at this stationary point. 314? Please tell me. If we are assuming that at x is equal to e, the function is having minimum, can this value be possible here? Please tell me. If we are assuming that at x is equal to e, this function is having minimum, then can this set of values be possible here? All of you, please think. It is not possible, which means this function is having maximum at x is equal to e. Correct? Because at this point, definitely it should have either maximum or minimum, because options are given that way. We don't have any point of, there's no option like this function doesn't have a maximum or minimum at x is equal to e. So definitely there should be either maximum or minimum. And if you take this minimum here, then this combination of options is not possible, which means this point is the point of maximum for this function. Did you all understand how to identify that this point is the point of maximum for this function? Yes or no? Did you all understand now? Which means this function f of x is equal to x power 1 by x has maximum at x is equal to e. Of course, this maximum is global, so which means this statement is also correct. And C is also correct, D is also correct. So this is the wrong option. And since they are asking not, answer is option B. Clear? Did you all understand this question? Because mathematically finding the second derivative of this function f of x means differentiating this function one more is so much of time taking. So since you have the access to calculator in exam, if you are able to access the calculator and you can calculate these values, it becomes very easy for you. Okay, so is that clear to all of you? Did you understand the logic behind this question? Now let us go for next question. 2020 computer science. Consider the functions e power minus x, x square minus sin x, root of x cube plus 1. Which of the above functions is or are increasing everywhere in this interval 0 to 1? Means in this interval at every point function should be increasing. How many functions are of that time? Are you getting the video? Okay. Because comments got stopped, so I felt that video is having some problem. So please try to answer this question. It's a very easy question. So please try to answer this. C, 1 and 3. Option C, 2 and 3. Okay. Then what are left with you? But this question is really a good question. Okay, so please try to answer this. Some people are opting for D, few of you are opting for C. Okay, so please, look this question carefully. C. Bivya, Suhas, both of you opted for D. Kamalajini and Divya, both of you opted for C. Okay, so let me solve this question now. Solution. See carefully. D. Okay, let us check. Let us consider the first function. What is this first function? E power minus x. Correct? Oh, C. Okay, let me check. What does this imply? F dash of x is equal to minus e power minus x. Correct? Now, in this values of x means if x belongs to 0, 1. Okay, let me write closed interval. 0, 1. This is positive or negative? Please tell me. Or for any values of x in general, this f dash of x, is it positive or negative? All of you please respond. It is negative. If this f dash of x is negative, can this function be increasing? If this is negative, can this function be increasing? Please tell me. I told you when defining, this increasing and decreasing function. So if this function is if this is less than 0, can this function be increasing? No, it can't be increasing, which means this function is not an increasing function, and which means option 1 is involved here. So this is not an option. Correct? Yeah, you can ask Shabnam Singh. Yeah, you can ask. Let us complete this question as well. Second, x square minus sin x. This implies f dash of x is equal to 2x minus cos x. Now, can this be increasing or decreasing? How to decide whether this is greater than 0 or less than 0? Please try to answer. How to identify this is less than 0 or more than 0? How to identify this is positive or negative? Keeping any value between 0 and 1. Oh, really? Look. Yeah, I know you will be doing this. That's why they gave this question in GATE examination. See here. Let us try to plot 0, x, y. The graph of cos x looks something like this. Correct? This is at pi by 2, of course. This is cos x. Now, if you draw y is equal to 2x here, it looks something like this. Of course, since we are talking in 0 to 1, I am drawing the graphs only within that range. Now, you know, at x is equal to 1, at x is equal to 1, let me draw this diagram a bit correctly. So, let me draw something in a better way. So, see here. This is y is equal to cos x, and this value is 1, because you know maximum value of cos x is 1 and minimum value within this interval, since this is less than pi by 2, this is pi by 2, so x is equal to 1 is somewhere here. Correct? So let me elaborate this graph so you can feel something. We want to know whether 2x minus cos x is positive or negative. Correct? So see here. 0, x, y. This is y is equal to cos x. Okay, if this is y is equal to cos x, this is pi by 2, and you know 0.54, which means or 1.57 probably. So you feel x is equal to 1 is lying somewhere here. Of course, scale, but try to understand. Okay, now if you write y is equal, if you try to draw y is equal to 2x, this could look something like this. Correct? Because at x is equal to 1, y value should be 2. But here the maximum value of cos x is y is equal to 1 only. Okay. This is what the graph looks like. This is of y is equal to 2x and y is equal to cos x. Correct? Now if you see something, these two intersect at some point. I don't bother what is that point, but if I call this as C, to the left of C, to the left of C, to the left of C, by putting x is equal to 0, we get negative value. Okay, then by putting something here, we'll get positive value, some value in between this. Okay, by putting a point left to the C, you can feel cos x is greater than 2x, which means 2x minus cos will be negative. It's evident because this y is equal to 2x graph lies below this cos x, and what is this value of C? I don't bother, but I bother that this C is in between this 0 and 1. Correct? Because by the time x is equal to 1, this y value will go to 2, but the maximum value of cos x is only 1, which means this line and this y is equal to cos x intersect definitely at some point between x is equal to 0 and x is equal to 1. Is that understandable to you? Till this moment, are you able to understand? Please respond. Are you able to understand till this point? So please respond if you are understanding the things. Because for this question, this checking option 2 means second function is the major part. Okay, so see here. To the point to the right of C, you can feel cos x is less than 2x. So 2x minus cos x is greater than 0, which means, can you understand, if this is f dash of x for a given function, if this is f dash of x for a given function, can you feel that this function x square minus sin x is increasing in some part of 0 to 1 and decreasing in some part of 0 to 1? Can you understand? I am summarizing this complete result of graph. Okay, if I say that this x square minus sin x is increasing in some part of the interval 0 to 1 and it's again decreasing from some part of the interval 0 to 1, will you agree with me or no? Please tell me. Did you all understand this point? At some part of the interval, the function is increasing because the derivative is positive. Similarly, at some part of the interval, the function is decreasing because derivative is negative. Clear? If that is happening, then you can't say it's an increasing function everywhere. No, it's not increasing everywhere. There are some points where this function is decreasing, which means you can't confirm this function is increasing everywhere. This second function is the major key for answering this question. Now third function is very simple to analyze. F of x is square root of x cube plus 1. So if you calculate f dash of x, it's of course very simple. 1 by 2 into root of x cube plus 1 into the inner derivative, which is 3x square. You know, for every value between 0 to 1, this function is always positive because x cube is always positive. For every positive, x cube is positive. So if x is lying in between 0 and 1, this x cube is positive. Positive plus 1 is positive. So square root is positive and this value is also positive. So greater than 0 at every point, no doubt, which means only this third function point, but not this second and first. Clear? Did you all understand this logic? Identifying the nature of the second function is the important thing in this complete question. If you are able to identify this, that's it. It's done. If everywhere is not given, then option C is correct, sir. No. Generally, if it's given only increasing, they mean it has monotonically increasing. Okay. In GATE, people are very much confined. They give the options in very, explanatory way. There won't be any chance for ambiguity. Okay. Generally, if there is some ambiguity at some point, they'll give the question as add many times. Add marks to all. Okay. So now I want to talk small difference between global maxima and local maxima. Okay. So see here. Yeah. So see here. Do we have any other questions? No. So see here. This concept is really important. If I ask you something, probably you should have the knowledge of graphs. If you have the knowledge of graphs, it's very easy to deal with such kind of questions. That's why in my basic mathematics course, I have spent one complete lecture on graphs. You can ask the students who have already attended it. Okay. So see here. Global and local maxima. Similarly, or minima, doesn't matter. And global or local minima. This concept is really important because sometimes in GATE exams, they can put this concept. There came questions, but since we have some limited time, I didn't put. So see here. Let us suppose you have some function like this. X, Y, function could be something like this. Some random function like this. Okay. Now, let me, put the things together. This is your x-axis and this is your y-axis. Okay. Because I just wanted to indicate this. 0, x and y. And let us suppose you have something like this. Okay. Now, let us suppose, this is the interval. 0 to, or let us suppose this is the value of x is equal to a and this is the value x is equal to b. Now, tell me the difference. What's the difference between local and global? Local means in general we used, it's a local boys, and all. Local means confined to some region. Global means over the complete world. Correct? Which in the same way in mathematics we have global means corresponding to the complete real number plane, minus infinity to infinity, or the complete real axis. Local is some part, some area in this world, maybe A to B. Okay. Now, if I ask you what is the local minima of this function in this interval, your answer will be this point. Okay. Because within this interval of A to B, this is the value where this is minimum. Correct? So this is called local minimum. Local minima. At every point tangents are 0, means derivatives will be 0. But this point is actually the global minima of this function. Did you all understand? Because whenever this interval is given, this interval is not taking care of the points where this actual maxima, global maxima and global minima are present. Okay, so sometimes using this, they'll ask you what is the local minima of this function in a given interval. For example, let us deal one question. You will try to understand. The local maxima of the function y is equal to 8x square in the interval minus 2 to 4 is dash. If this is the question, questions of this kind came in GATE examination, so I'm telling how to answer you this kind of questions. So see here, we'll learn the concept of global maxima, and of course whatever we are doing, finding first derivative, then considering the second derivative test, and all these are global maximas and minimums. So let us see what happens whenever some interval is given in the question and they are asking for maxima or minima. You need to do something excess than what you are doing for standard procedure. See, what is that? Look, if you try to plot this 0, x, minus x, y, and minus y. You know, y is equal to 8x square looks something like this. This is y is equal to 8x square. Correct? Now see here. Normally, if you adopt the standard procedure which we are doing for global maxima and minima, let me change the color so you can understand. Is equal to 8x square. Correct? We generally treat y as f of x, so y is equal to 8x square. If you calculate the first derivative, you will be getting 16x, and if you equate it to 0, you will be getting x is equal to 0. If you calculate second derivative, this is 16. Correct? Because if first derivative is 16x, second derivative is 16. Now in exam you will get stuck at this point because in the question they are asking for maxima. If you want maxima, your second derivative should be less than 0. But what did you get here? First derivative as second derivative as greater than 0, and you have only one stationary point. Correct? This is the point where you get stuck in exam because you got only one stationary point, and at that particular stationary point, this second derivative is positive. But in the question, they are asking for the maximum value. Now, what to do? Because as per our global maxima minima analogy, if you want to have maxima, this should be negative, but it's not the case here. Correct? If you read the question and if you understand the English in a good way, you can answer this. They are asking what is the maxima in this locality interval. So if you consider this point as x is equal to minus 2 and maybe this point as x is equal to 4. Of course, my diagrams are not up to the scale, so please try to understand. If this is x is equal to 4, they don't want anything about this part, and they are interested only about this part of the curve, which is in this point. Now, along with calculating f of this stationary point, you can anyhow calculate f of 0. 0. Along calculating with the function values at stationary points, also calculate f of a and f of b, means the interval points. Calculate f of minus 2 and also calculate f of 4. Okay, if some interval is given in the question, then along with the procedure for maxima and minima, you boundaries of the interval. Now, if you calculate f of minus 2, if you put the answer is 32. F of 4, if you put 8 into 60, 6 8s are 48 and 128. Correct? 8 into 16 is 128. Now, out of these three things, which is the maximum value? This one. This is the maximum value. So the answer is 128. This is what you should write. Okay. If you adopt the procedure for global maxima and minima, you'll get stuck at this particular point, which should not happen. Clear? Is that clear to all of you? They are asking about the maxima in this interval, and you have the maxima here correspondingly. So in this question, definitely after calculating functional values at stationary points, you should also calculate the functional values at this boundaries of the interval. then whatever they're asking for, if it's getting maximum, you'll write this. If they're asking for minimum, you will write this. So out of these three, whatever is maximum or whatever is minimum, they will mark that as correct answer. Clear? Is that maxima and minima? And do you feel that we solved some good questions today? You learned something today? I'm sorry for that. Maybe net signal got stuck here since long back, but I am able to read comments. Correct? So please tell me, since we have completed some differential calculus of first module, half of the first module. So please tell me, are you all understanding the things? Is the teaching going fine? And are you all understanding the things? Please reply me, because that should be done. Correct? If you're not understanding anything, there's of no use doing this. Correct? Okay. So able to understand, that's, I'm very much happy for that. So in some integration techniques. Okay. So please don't miss tomorrow's class, because tomorrow's class is the first class of integration. And many people feel integration as a bit difficult, but there's nothing like that. We'll make it easy, and we will be able to solve all previous gate questions with the knowledge what we gained in this class. Okay, means in this course. So please try to attend tomorrow's class. And anyhow, these are the contacts. For notes, you can always scan these two groups. This is for mechanical students, and this is for all other branches excluding mechanical. Okay, so anyhow, daily, this is the only place where we are uploading all our materials, notes, and access questions and all. And for any contact or for any information regarding future batches and all regarding any other exams, we don't only run batches for GATE and all, we also run for different other exams, so of national and state importance. So you can always contact these numbers for getting any personal information. And of course, if you want to come and visit our office, definitely you can. The office is located in Visakhapatnam, Daba Gardens. Okay, so I hope things are clear. Correct? So then, do you have anything to talk, or can we leave this session? Is that okay to all of you? So please, if you are liking the content that's being delivered here, you please like this video and put some good feedback, and then you can share this video to your friends. And for getting notifications all the time, you can subscribe to our channel. Thank you all. Good night.